Hello everyone. I am Faizan Khan from Sri Venkateshwara College of Engineering. I am studying in fourth semester of Data Science branch. Today my topic is Fibonacci series implementation through recursive function. What are Fibonacci numbers? It is a famous sequence which by default starts by 0 and 1, and it further increases with each number is equal to the sum of previous two numbers. Means the 0 and 1 in the above series is its default, and it goes on increasing by the number which are equal to the previous two numbers sum. Okay, what are the real life applications of Fibonacci numbers? Art and design. In art and design we use these Fibonacci numbers has a golden ratio. In photography also they will use this. uh, we can also use this for predicting the prices of stocks, and in computer science you can use this for various algorithms. Okay, before going into the recursive function we have to give two initial conditions. The first two initial conditions are f of 0 is equal to 0, f of 1 is equal to 1. uh, the we have to give the recurrence function, which can be defined below. F of n is equal to f of n minus 1 plus f of n minus 2. Means this function is going to be implied for n is greater than 1. Okay, this algorithm, what it does, it computes the nth Fibonacci number recursively by using its definition. For input, we are going to give a non-negative integer n, means it must be positive integer. And for output, we get the nth Fibonacci number. If n is less than or equal to 1, return n. Means if the value of n is 0 or 1, it will give the value output has 0 and 1 itself. If you give 0, the output would be 0. If you give 1, the output would be 1 itself. If the value is exceeding 1, then we get uh, by executing the else statement, return f of n minus 1 plus f of n minus 2. By recursively calling this function, we get the recurrence, and we get calculated the Fibonacci number. This is a recursive call tree. It calculates the fifth Fibonacci number by definition based algorithm. See here, f of 5. It is going to make two calls, f of 4 and f of 3. F of 4, we can tell it as f of 5 minus 1, and f of 3 you can call it as f of 5 minus 2. And further, f of 3 is getting divided into two recursive calls, f of 2 and f of 1, which you can also indicate it has f of 3 minus 1 is equal to f of 2, and f of 3 minus 2 is equal to f of 1. And f of 2 is goes on calling the recursion of itself, and it calculates a fifth Fibonacci number according to this tree. Okay, if you want to calculate much faster, you can also implement this algorithm by computing the successive elements of the Fibonacci series iteratively, as it is done in the following algorithm. Means here we are not going to use recursive function. We are going to use uh, iterations, by which we are going to calculate the Fibonacci number here in this algorithm. F of 0 is equal to 0, f of 1 is equal to 1. Here we are using loop also, means it goes on iterating, and it will goes on executing the functions, and it will return f of n. Time taken to execute this Fibonacci series by implementation of recursion function is t of n minus 1 plus t of n minus 2 plus 4 units. This 4 units indicates the 4 operations which we are going to use in that calculation of Fibonacci number. T of 0, and it is equal to t of 1 because only one operation is going to be executed in t of 0 and t of 1. Okay, what is the lower bound of a Fibonacci series through the implementation of recursion? 2 power n by 2, it will be the lower bound. and the upper bound, which you can also call it as big O notation, it is 2 power n. Okay, big O of 2 power n, it is an exponential time algorithm, and big O of n, it is linear time algorithm. If you compare these both time algorithms, the more time will be taken by exponential time algorithm, but the linear time algorithm takes less time, because the linear time algorithm, it depends on the input size, but in the exponential time algorithm, it goes on increasing exponentially. Thank you.